Welcome to the Department of Design and Engineering at Bournemouth University, and thank you for your interest in our programs. We hope this presentation helps in making your decision on which course is best for you. Based on two different campuses, Bournemouth University is a diverse community with 2,000 international students, peers of international reputation being listed in the top 200 of the Times Higher Education Young University Rankings 2018, which makes us feel very proud.
Our main capital investments have been in modern resources and infrastructures, including a student centre, the Fusion building, with seminar rooms, studio space and eating facilities, a recently refurbished sports centre and a design and engineering innovation centre, where our workshops are.
There are many student clubs and societies students can join, and also bars and restaurants on campus and in town that will make you feel part of a vibrant community of staff and students.
Design and engineering programmes are based within the Faculty of Science and Technology. The faculty has around 3,000 undergraduate students and the Department of Design and Engineering around 550 students studying one of our various programmes.
Our programs range from pure design on one end of the spectrum to full engineering on the other end. For those who are interested in an engineering related subject, then we offer mechanical engineering and design engineering. Mechanical engineering is a broad engineering subject, so graduates can work in any industry. Design engineering may be of interest for those who have an engineering mindset, yet they have a passion for design. For those more interested on design, then we offer product design, which is amongst the best in the country and has a strong workshop, hands-on approach, and product design futures that looks at the future of design from a more conceptual point of view. We also ran 3 master's postgraduate programs and 2 integrated master's programs that link to our undergraduate programs. Learning at Bournemouth University may be quite different from the past experience of students. We encourage interaction between staff, students and their senior peers. That is why all our programs have a program leader. Each student has a dedicated academic advisor to support students in particular areas where they might be struggling, and there is a student support and engagement coordinator where students will be able to discuss confidentially and away from the team if they wish so. We also ran a peer-assisted learning system where senior students support the integration of first-year students into university.
Based on what we do for supporting students, we were the first university to be commended by the Quality Assurance Agency for Higher Education for the quality of student learning opportunities in 2013.
Teaching is delivered with a balanced mix of lectures, small seminar groups and tutorials.
By splitting assessments into small chunks of coursework, lecturers can give feedback that we can then use to improve on our next assignment.
All support we need, including teaching materials, discussion forums, timetables and library resources, are accessible through a virtual learning environment called Brightspace.
We've been in design education since 1989 when the Innovative Product Design programme was developed. This was the first of its type in the country, and the Institution of Engineering Designers, in defining the accreditation standards needed to become a recognised product design course, then adopted the Bournemouth programme objectives. Now, all of our courses are based on this long history of design education and have changed and evolved to keep up to date with the latest industry requirements.
Being a university, we also engage not only in education, but in core research and professional practice. This allows us to develop new knowledge and innovative ideas that are passed on to our students, and to work with professional bodies and different companies which link all develop into real-world case studies to bring into our programs.
This opens up access to a professional network of designers and engineers. While students and graduates go through their careers, they can use that accreditation to become registered product designers or incorporated engineers, typically after a bachelor's degree, up to chartered technological product designers or chartered engineers in the case of an integrated master's degree, which are important professional titles to have, as these recognitions open more opportunities for students in our careers.
All our courses were accredited by at least one professional body until 2018 and are seeking re-accreditation for the 2019 entry. In what is normal process that happens every 3 to 4 years. Product design is seeking re-accreditation by the Institution of Engineering Designers, and design engineering and mechanical engineering are are seeking reaccreditation by both the Institution of Engineering Designers and the Institution of Mechanical Engineers. Product Design Futures is a new course which will be applying for accreditation in line with the other programmes.
Design at BU is supported by extensive facilities that allow students to go through the design process, leading from the concept stage, that's the studio space where students can do the design thinking of sketching, through the virtual space, and that's the students can take those ideas through to computer-aided design models where they can do simulation, visualization and high quality animation. Through to the physical working space, that's the workshop space where students can build these products.
We're very excited to say that we have recently had our new Design and Engineering Innovation Centre opening. These facilities host a new modern workshop environment. We've integrated virtual reality into our enhanced prototyping centre for 3D printing. We've incorporated an electronics laboratory and manufacturing centre, and we have two labs, one that deals with mechanics, dynamics and materials, and another with heat and thermofluids.
When using these facilities, students are continuously supervised by a dedicated team of highly qualified professionals who support students during all the time they spend in the Innovation Centre.
All our programs have a placement within the third year, so throughout the first and second year we offer a lot of support in developing students' CVs and interview skills to be able to get that placement. We have students going all over the world for different companies. The fee for the placement year is a fraction of the normal fee to cover the admin support. And at the same time, we would also be expecting students to get paid for the work that they are doing while they are out there in industry. That experience is invaluable for their final year, and as they move on into their full careers, as this experience is also recognised by the professional bodies.
Our employment rate of students who are employed within professional role within 6 months of graduation is extremely high. In fact, many of our graduates have succeeded in joining the world's most renowned companies in their sectors, or they've created their own success stories through startups with the commercialisation of their own ideas, some of which they developed while still here at university with us.
Each year we host what we call the Festival of Design and Engineering. That's where we celebrate our students' time at university. Students would do their final projects and be able to present them at the show. Lots of industry comes to this show, and students get a lot of opportunities for job interviews and presenting their final work to industry scouts.
We also send a number of students off to New Designers in London, in what's a national event. And we've done very well at that in recent years. We've won a number of national awards at the show, showing that the work from our students is being recognised nationally.
Our students have also won many other awards over recent years, again showing that student work is of high calibre and recognised nationally. The other side of this is to think about potentially students could be developing a project or a product that could become a commercial success. Probably the most recognisable one is the Quick Pitch tent that was designed by one of our product design students while still at university.
We try and engage heavily with the professional bodies associated with our field. So with the first year design, engineering and mechanical engineering students, we run something called the IMechE, or the Institution of Mechanical Engineers Design Challenge competition, and for 3 years we have won that in the local Wessex region against other universities in the region, having come second in one of the national finals in the IMechE headquarters in London. This gives the students a real chance to meet other students of engineering courses across the country and to engage in a lot of the elements that are required to become a professional engineer.
We also sent a team composed by a mix of students from different programs to participate in the Global Grand Challenges competition promoted by the Royal Academy of Engineering. After a challenging competition, first at national level in London and next against teams from the United States and China, Bournemouth University students came second in the international final held in Washington, D.C. and were awarded $15,000 prize money.
Entry requirements for design programs are a minimum of 104 to 120 UCAS tariff points, including a minimum of 2 A levels or equivalent. These courses also require GCSE English and Maths grade C or grade 4 in the reformed GCSE grading. All applicants are interviewed at a portfolio afternoon. This is a relaxed one-to-one 15-minute meeting where applicants have an opportunity to discuss their portfolio, their design work, to one member of the academic team.
In design engineering, we want to see examples of technical work that students have created before. This could be science or technology rated, from school or external project at any level. It could be things you've worked on at home in your own time.
For product design and product design futures, we are looking at having a good overview of students' creative work and problem-solving abilities. For example, through drawings, model making, workshop activity or school projects, as well as projects outside school.
There are 3 design degrees at Bournemouth University: BA Product Design Futures, BSc Design Engineering, and then Product Design, which is also split into 3 variants. On this diagram you can see how the programmes are related to each other. If you look at the horizontal axis, on the left we have BA, Bachelor of Arts, on the right we have BSc, Bachelor of Science. The further to the right, the more technical aspects there are in the programme. So for example, as you would expect, design engineering is the furthest to the right as it includes the most technical elements in it. Product Design Futures is the furthest to the left as it's a pure BA programme, and the 3 versions of product design sit firmly in the middle, have a big balance between the BA humanistic elements and BSc the technical elements. The vertical axis indicates the kind of outputs that come from the programme. So the further towards the bottom, where product design sits, the more there is a reliance on building physical prototypes of what's being designed by the students. Design engineering, you can see, straddles the axis. The students will build technical demonstrators, use simulation tools to virtually demonstrate their design solutions. Product Design Futures is just above the horizontal axis, so it's more towards the virtual output, the virtual product. So students will be utilising high quality visualisation, animation and simulation along with virtual reality tools to present their final design solutions. And you'll understand why as we go through the talk. So we're going to start with introducing to you the product design programmes. So this first slide demonstrates the kind of activities that students will engage in the product design programme. So there'll be sketching, working in groups, project critiques, building quick prototypes, going in the workshop, developing fully functioning prototypes and presenting their work to clients. We believe that to go into the product design profession, students need to be able to demonstrate these 3 C's. They have to be creative, want to develop new concepts, new ideas, products, curious. You can't be a product designer if you don't know what's going on in the world and what problems there are that need solving. Certainly commitment. This degree requires you to spend a long time in university developing, designing, building prototypes. And confidence. To be able to get up and present your design, to sell your design to clients, requires you to be confident about what you've developed. And the quote down the bottom is something that we believe is typical for design. Design is not a profession, but an attitude. It's got to be in your blood. It's something you really want to do. So, what is product design? So this is the definition of product design by the Institution of Engineering Designers, the professional body who accredits this particular programme. And if you look at the highlighted words, it really defines how we deliver product design at Bournemouth University. It's about developing creative 3-dimensional solutions that have both a humanistic and technical aspect to them, and they're developed for the user and have commercial viability. The scale of the kind of products that students develop is generally represented here on these slides. Students have to build a prototype So they're not a full working prototype, so they're not going to be developing something extremely large that they can't manufacture in the workshop. Equally, if it's extremely small, again, they would not be able to manufacture it. So, for example, you can see here on the right, a student designed a new type of food carrying box that could go on the back of a bike. Bottom right, the student developed some new kind of toys. In the middle, a lamp, and there are other examples here as well. So how do the three variants of product design work? So importantly for product design at Bournemouth University, whether you apply for a BA, a BSc or an MDes place on the programme, you would all be doing exactly the same thing in year 1 and year 2. Because as we said at the start, for us product design involves both the humanistic and the technical elements. So both BA students will have to engage in the technical elements and the BSc students will still have to engage in the humanistic elements. After those first 2 years, students will go out on a placement and then come back to select their final major project, and that will determine whether they will be going on the BA route or a BSc route. All the projects again in the final year will have both technical and humanistic aspects, but the emphasis on whether the project is slightly more technical or more based on the human will determine whether it's a BA or a BSc project. So there really is a deferred choice on whether you want to be a BA or BSc student till that 3rd year of the programme. We've also more recently created a 5th year if you're studying after doing a placement, or a 4th year if you're studying full-time, to allow you to graduate with an MDes product design. So the MDes programme is an extra year at master's level, and that's required if you would like to become a Chartered Technological Product Designer, which is a registration given by the Institution of Engineering Designers. So here's the course structure for product design. So you can see that level 4, which is year 1, and level 5, which is year 2, are studied by all students. Then students then go out on a placement year and will come back and to level 6 and then study either the BA or the BSc route. So students who end up studying on the BA programme would do the BA option, the Design Studies 3 option, and those studying the BSc programme would do the Advanced Technology option. And then you can see here the level 7, the MDes level. So typical process for design, students will be either given or have to develop design briefs, or carry out research to understand the nature of the brief. From that we'll develop some concepts, we'll undergo some testing, it might be card modelling, foam modelling for example. After that, more research might be needed to further develop design. Final or more design concepts are generated, more testing, and then hopefully after that we have a final concept which then needs to be presented. Here's an example of a typical first year project where students are learning to integrate some kind of technology into a small highly mass market produced item. So here we did a humane mouse trap. So the students would have to design, develop, build a prototype and present their final design. Here's an example of a typical second year project. So the student was able to select their own brief and decide to look at the concept of footwear that could expand as a child grows. So they looked at picking products that fit into a certain range, in this case Adidas, developed many design ideas. From that created a prototype of their design, then a fully final prototype which you can see here on the right, and their final design concepts which you can see here on the left. This is an example of a final year BSc project. So the student was looking at, in the third world, in disaster zones, the need to be able to incubate babies, keep them warm, All devices out there at the moment are really high cost, require an electric source to be able to power them. So he developed this Snug, which is battery powered, much more low cost, robust for those kind of environments. So this device was actually built and fully functions to requirements. Another example of the BSc project is this pressure canister. So this was an Institution of Engineering Design's student award winner, and also there's a lot of interest in taking this project forward commercially. So normally buy tennis balls, use them a number of times, pressure goes, have to either get rid of them and get new ones, which is expensive. So this device will actually keep the tennis balls pressurised, and will repressurise balls once put into the canister, and will also tell the user how much pressure there is in the ball and whether they're good to use or not. This was a BA project, so very much focused on our understanding in current culture about that our children are sedimentary, they're not moving about much. How can we get our children moving around in their environment? So the student developed this game called Pop It. So the little puppets will pop up, the student has to follow them around, push them down, and there's a control centre through the little card that goes with it. There's a game that will count how many times the puppets have been pressed down. So even though this is a BA project, you can see there are still technical elements within it. Right, so moving on to the newest of our degrees, Product Design Futures. So whereas you've just heard from product design, we're looking at the development of mass market products, taking them to full concept for development. In Product Design Futures, we're taking away those constraints. So the students are looking to develop for the future, not for the now. So they'll be learning about the current global trends, the challenges that are going to be faced globally that we need to address to be able to ensure that we live in a sustained environment. So it's looking to the future of the design industry. The course has a common first year with product design, and we've also developed this programme to meet the requirements for a registered product designer from the Institution of Engineering Designers. So the course structure is very similar to product design, except that we do not have a level 7 and master's level on this programme. So it's 3 years full time or 4 years with a placement year. So as I mentioned earlier on, the first year level 4 is common with product design. Then at level 5 it starts to deviate. So you can see on this programme we have a unit called Future Trends and Sustainability, which is very much about introducing those concepts that I talked about earlier, about the global challenges, about what's required and what kind of technology is going to be developed in the future that we can use in design, and how we can ensure that these designs are going to remain sustainable. And they will use that knowledge in their Design Futures projects units. And those themes carried forward into the final year with Future Trends Sustainability 2. And we have this visual concept communication unit is where the students will be learning how to create really high quality visualizations, renderings, use virtual reality to demonstrate their design concepts. As in this program, students could be designing anything from the microscopic scale through to the size of a football stadium. So just to get a feel for the kind of quality of outputs that we would expect the students to be achieving, here you can see some renderings from the packages that we're going to be using for the presentation of the final products. So it becomes very hard to tell whether these are actual products or actual computer representations. I mentioned virtual reality. This is a tool that's been increasingly used in the design industry, and it allows the user to be immersed in that environment with that design. And students will be utilising it both in the process of designing the products that they're developing, and also to show that design off to the user. They'll also utilise advanced manufacturing technologies such as rapid prototyping, 3D printing, to be able to demonstrate certain aspects of their products. Some of the challenges that we're trying to address within this programme. On the left, you can see how the price of domestic energy in the UK is increasing year upon year. We're filling up landfill sites with also blue planet, and the plastic that we have in the oceans is a problem that we need to deal with. So we're very much going to deal with the idea and notion of a circular economy. How can we take what we develop and ensure that we design it right through the full life cycle to be able to be returned and reused rather than to be thrown away. So this fits within sustainability agenda. So we're looking to design products of the future that are more durable, recyclable, biodegradable, will use renewable energies, have lower energy usage. So just to remind you how this programme is different. So we're looking for these students to be able to predict the future of the design market, to be able to understand the technologies that are going to become available that we can integrate into our design solutions, focusing on more the virtual output than the physical output. So it'll understand materials, emerging technologies, will involve wider sustainable features. So the final programme that I'm going to talk around is our BSc Design Engineering programme, which is the most technical of our design programmes. So a design engineer, they're the person who works with the whole design team, with the marketeers, with the engineers, with the designers. They're really that person in the middle who can communicate with all sides of the design team, and quite often find themselves becoming managers of that team because they're able to understand both the designer and the engineer perspective. So they're directing the design process and driving innovation. And as part of their role, they'll deploy a range of different engineering disciplines to solve those design problems. And the whole emphasis is on ensuring that that product will function and perform as it's supposed to do. It's going to be fit for purpose. So the whole course philosophy is around devising engineering solutions to design problems. And again, we are focusing on both solving problems that are for the mass market and could be the niche market for one-offs. To speed up design time, students will learn about the latest advanced computer tools for the design process. And also to note here that this programme is accredited by both the Institution of Mechanical Engineers and the Institution of Engineering Designers to what we call incorporated engineer level. Again, the students will study for 2 years, level 4 and 5, go out on the third year on placement and come back to their final bachelor's level year. So in terms of the kind of projects that students get engaged with, many are industrial related, and here are some examples. So if we look directly top middle, you can see a frame kind of trolley device. So this was in response to working with the Bovington Tank Museum, who restore military vehicles. They wanted to take the turret off the top of the tank, extremely heavy object, but there's only ever going to be one of these devices required. So students had to understand about the processes and the tools and technologies and materials they would use to develop such a system. So very much using bought off the shelf materials that could be cut easily, welded together, easily developed solution. No tooling required that would cost lots of money just for a one-off process. On the right, or top right, you can see an example of where students work with a company called Parvalux, which builds electric motors, and the company set a challenge of designing a commercial device that would allow to use their motors to turn a bike into an electric bike. So the students had to understand all of the mechanisms or understand the motor, understand how to connect and develop the drive chain for such a device. And this was going to be a more commercial device, so the students were able to look at solutions where you would need to develop your own tooling to be able to manufacture parts. I mentioned earlier on that we use design analysis tools and simulation tools to speed up the design process, and here's an example of 4. So on the top left is an output from a tool called finite element analysis. So we can apply virtual forces, virtual loads to our object and can understand how that object behaves under the loads, how it will be to form, how much stress and strain will be in it, will it be able to take that load before it breaks. On the bottom right you can see the output of a tool called computational fluid dynamics, or CFD, where we can put virtual airflows or liquid flows over an object. So in this example we're looking at the flow over the fairings of the bike to look at the aerodynamics. The other 2 tools you can see, they're electronics based tools. The bottom left is a tool where we can develop virtually our printed circuit board, our electronic circuits, and test them to make sure they're going to work before we manufacture them. And top right is a program we can build our microprocessors. So on this program, students will look at both the mechanical and the electronic elements of the design. Here's an example of a final year project. So this student developed the heat harvester. So it was using a concept called Peltier device, which when you have a gradient in temperature between one end and the other, so a hot end and a cold end, you can generate electricity between them. So the student did some analysis in finite element analysis. They built a little mock rig, which you can see on the right, to test that the concept works, and built it into this wand. So the wand telescopes out, one end can go into a heat source such as a camping fire, and it will generate enough electricity to plug a USB port on the other end to charge a device such as a mobile phone. So it might be something that's useful for campers, those who need to go into extreme environments and use devices such as torches, etc. that need to be charged. Here's another project that was undertaken by one of our students. So the student developed the Bright Boy, which is a waved powered navigational aid. There's lots of technical elements that have gone into this design, using hydraulics and spring turn cylinders, had to design electronic circuits as well as the mechanical elements of that project. This example is the student took the design of a pallet truck one step further. So pallet trucks are normally manually driven and pulled backwards and forwards when they're loaded up with items, but he made this truck also have a motorised power on the base so that it could be driven around without any effort whatsoever. So he had to devise and develop the hydraulic circuit, which you can see there on the left, using some of the tools that we have available in terms of simulation. Used obviously manual calculations to help solve the problem, and at the bottom is fully rendered final computer-aided design model of what we developed. So again, the fields that students go into, wide and varied, and having that electronics and that mechanics knowledge along with the advanced simulation puts them in a good place to go into many different industries. So for entry onto any of these design programs, we're looking for 2019 for a student to achieve between 104 and 120 UCAS points, and that should come from a minimum of 2 A levels. If we look at the conversion table on the left, you can see that 104 points is equivalent of a BCC in A levels to 120, which could come from a BBB, for example. All applicants are invited to an interview afternoon, and it's at that point where we will decide to offer to the student, and that happens through an informal 15-minute discussion with an academic member of staff around a portfolio of design work that we're asking you to bring along. If you're thinking about what to put in that portfolio, we're not prescriptive. For product design futures, we'd just like to see a good overview of your creative work and how you can solve problems. So it might be drawings, Might be examples of models that you've made, could come from school projects or projects that you just do in your own time. Design engineering, again, not prescriptive about what you bring along. Might be examples of any technical work that you've done, or science or technology related work, again from school or externally. The main thing we want to see from you in the portfolio discussion is your desire and enthusiasm for the programme that you've applied for. Alongside your interview, you'll also have submitted a UCAS form. So again, in the first instance, we want to see from your personal statement your enthusiasm for design come through.